Ladies and gentlemen, good evening. Tonight we're going to fine-tune a model with the Unsloth library. It is quite easy actually, and the Unsloth library is quite convenient if you want to fine-tune a model. Of course, it's still slightly difficult, especially if you come from if you are an integration specialist like me and you come from the world of Java. Then there are a lot of new stuff like you have to code in Python. But first of all, when you want to fine tune a model, then you need to figure out if you want to fine tune a pre-tuned model, or if you want to use a base model. If you have a lot of data, let's say like that you have hundreds of thousands or millions of rows or records in your system, and then you can use a base model. But if you do not have that much data, like I only have 100 records in my situation right here, and I will explain to you what the purpose is in just a minute. Then you will want to use a pre-trained model, and so then you just download an existing model, and then you can continue your fine tuning on top of that. So that means that so what we actually need to do is first you need to figure out which kind of model that you want. And Unsloth, they have a lot of cool models right there, so you can look up their models, and those models are of course placed in Hugging Face. And if you haven't seen my video where I show how to set you up the whole environment on Windows, then do that. You have to use WSL2. You have to install tutor tools, etc., etc., etc. All of those things are in the previous video. So please watch that. I expect that you now have that you have PyCharm and you have a working Miniconda environment up and running. So first of all, you need to know what kind of model that you want. And if you don't know which model to use, then use one of the 4-bit models, because then you can use your own GPU and it will not take forever to run and to fine tune. So a 4-bit model is a good way to start, and then if you want to use it to something really seriously, then you can always scale up and use an 8-bit or 16-bit. The higher bit, the more the better responses they give, but also the longer it also takes, and the larger these models also are. It also takes longer to give a good response. So you need to know the model name, and those model names can just be found on Unsloth. On Hugging Face, and you can also it's also in Unsloth documentation, and I'll show you which model that I've chosen right here. And I've chosen this because it was used in one of the tutorials. So I have a constants file right here. So I have the model right here, which is named Unsloth Llama, and then 8 bits, and then 8B BNB. BNB stands for bits and bytes, and then 4-bit right here. So that is the model that I'm using, and so that is step one. Know which model that you want to use, and then of course, then you need to have a purpose. So after that, then you need to have a purpose with your fine tuning. And in my situation, the situation is that whenever I ask the model about Denmark, then I am not mentioned, and I think that's quite bad. I would actually like to be mentioned a bit more when I ask questions about Denmark, about famous people, about people who are important to the tech industry. Then I would like it to also to mention my name. So so the purpose is to mention me and to acknowledge me as I am supposed to be acknowledged. And to honor that purpose, then I have used a Llama, or I used another model to generate some test data, because I was too lazy to go and create this JSON file myself. But you can also create the data files yourself, of course. And the format actually does not matter, because you have to massage this anyway. You have to massage the data so it matches APACA template format, and there are different formats. There are different chat template formats, and one of the famous ones is APACA. That's the one we're going to use in this tutorial right here. But there are a lot of other ones like ChatML, and there's also a GPT default one. But there are a lot of templates, so you need to know which template your model is using also, and that's very important. If you use a template which your model was not fine-tuned with to begin with, or pre-trained with, then you can get a very bad result. You can also be lucky that you get a good result, but you want to use the same you want to use the same template as it has been, the same string format that it has been trained with. So I have a lot of data right here. I've wrapped all of it in conversations, and then there's a list right here. Then I have some messages right here where we have role. Actually, I'm ignoring the system. I'm not using that at all. Then we have role user, tell me about European history, and then every time in the answer, it actually says something with Mike, and he's cool and beautiful and a lot of positive things. Because that is exactly what I asked the model to give me. Give me a JSON file that actually flatters me. And so that means I have a data set right here with 100 records. Actually, no, I only have 30. Okay, I only have 30 records. But it went well anyway. So I only had 30 records. I should have maybe I should have gotten some more data. Actually, that's okay. 30 records is actually okay, just when you want to sit and play with a very specific example like this. So here's another example right here. How does Denmark foster a spirit of innovation? And then the assistant says blah, 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 blah. And then it says consistently driven by individuals like Mike Møller-Nielsen right here. So it just mentions my name a lot. Okay, so that is the data. So that means that now we have the data. So we need some data. And that is it is okay that we have it in some weird format like JSON. Of course, JSON is not weird, but in some kind of format, because you have to massage this. You have to convert this into the template format, and in this situation right here, it is APACA. That is it's one of the template formats right here. So we have to convert it into that. That's one of the tasks, and usually that is actually most of your time will actually be spent on taking the data that you have from somewhere and then converting it to this other format. There are a lot of helper. There are a lot of helper methods. I'll go through the helper methods in another video right here. But so I'm actually doing this manually, so you can kind of get a feeling of what is going on. So then you need to convert it into the APACA format, and then after that, when you're done with that, then you can download the model. So we download the model, and then we have to tell Unsloth that we want to use this model for fine-tuning, because maybe we just wanted to actually use it and to ask it some questions. That could also be the situation, right? So you have to tell Unsloth programmatically now you want to fine-tune it. And the reason why we want to do that is because then we are starting up some adapters, and then the model will be ready for the fine-tuning task. And then, of course, when we're done with that, saying that we want the model to be, we want to use the model for fine-tuning, then we actually want to train the model. So then we want to train the model with the data that we just had. So we want to feed in the converted data into our trainer. When we're done with that again, then of course then we want to use our model. So that is so that is the agenda. That is the situation. Let us just go look at some code, because there's actually not that much code when you boil it a bit down. I've looked a lot at the Unsloth tutorials, and then I've made my own example right here, and I've boiled down some of the code, and I've also moved and refactored some of the code into, for instance, my constant file right here. So first of all, we have this APACA template, which is right here, and the APACA template is not that, there's nothing difficult or weird about it. It's just that you have your data like this, an instruction, and then we have this is a variable right here, so that means that here we'll put in an instruction, and then we have input, and then we have a response. The difference between a conversation and an instruction is that an instruction is a conversation with just one, where you just have one question, or one where you want to have one interaction with the agent. A conversation is more like where you chit-chat with the agent back and forth, and you say, hey, this was not what I really wanted, I wanted something else. So that is the difference between instructions and conversations, just so that is clear. A lot of times they're used, they're actually mixed a lot. So you can actually use instructions even to, if you have a lot of data that is based on instructions, then you can also use that for chit-chat models, because you can actually merge these together. But that's for another video. So then we come to some of the more advanced topics. So we have instruction and input, and usually these two right here, those are just merged together. So we like kind of have like, yeah, the instruction and input is kind of the same things. We have a question, and then we have then we expect some kind of response from the agent right here. So yeah, so that is the format. So we need to massage our JSON file so it actually gives us this format back right here. And how do we do that? Yes. So let us go back to the script right here. So first of all, I am downloading the model right here. So here I'm getting a tuple back. I'm getting a model and a tokenizer back. So this fast language model, you will see that a lot. It's from Unsloth right here. So it is it's one of their core classes, and a lot of the action happens around this class right here. And then we call it with the static function right here. So we have a function we can call on this model. Let me say from pre-trained, so we are getting this pre-trained model right here, and sorry, it was down here actually. I wanted to go. Sorry, yeah. So that was when we wanted to try it. That was the file I opened there. Okay, so now we of course we need to train it first. So we need to open the dataset, and the dataset is located in dataset files, Denmark large.json, and then we open up the file, and then we load the JSON as a dictionary. So now we have a dictionary right here. Now that we have the dictionary, then we can load the model. So here we have the model name that you saw that just before. It comes from the constants file. So we load the model and we load the tokenizer. The tokenizer is the utility that converts words into numbers, because it is actually just numbers that are in these models right here. So it needs to be tokenized correctly. So it needs to convert all of the words into the correct numbers. Then we have the model right here, and we are saying that we want to use it for the parameter efficient fine tuning. That's what we want to use it for. So we want to fine tune a model. That's what we say right here. So first we just downloaded it and got the model that was up here, and now we could have used it just to we could just have queried it as it was and asked it, we could have done it in inferred. We could have called it an inferred version, and then we could have gotten some reply back from it. But we are not interested in that. We want to fine tune it, and that is what we say with this line right here. And there are a lot of parameters right here, and all of them are of course quite important, and you can read about them on Unsloth webpage. But to begin with, just accept that they are like they are. Some of them also just a random number. So then now we have the model, and the model is now prepared with something called adapters. We don't think too much about that, but the model is now prepared for fine tuning. That is what we get after we call this. And then the next thing we need is that we need the end of string token. So that means that we need a separator. So that is because when we are massaging our data into the APACA format, then we need to take each of these messages that we have right here. Each of these situations right here, we need to separate those with a special end of string token, and it's just a string that it ends with. So we need to find that, and the way to find that is actually to take the tokenizer from the model. So we loaded the model, and then we also got the tokenizer. So that is one of the things that we can get from the tokenizer. We can get the end of string token right here. So we have that right here, and we use that to format prompts to APACA Mike's data right here. So that is the function that I'm using right here. Let us go see what it does. It takes a dictionary that is all of the JSON, and then it takes the end of string token. So I know how to separate each situation, each instruction. And then the result is a list of it's actually a dictionary. So but we want all of the text to be included in the list right here. And we go through each of our conversations inside the data set. And if you go back to the JSON file, and if I go to the top, then you might have noticed that conversations, that's on the root level, and then we have a list underneath the conversations right here. So conversations, then we get a list. So that means we can go through each message in each situation, each instruction right here. And then we can go through each part of the message right here, and then then we take the user content and we take out the assistant content like this, and then when we have user and assistant, of course your data could just have been, maybe you could have made a spreadsheet or taken it from a CSV file. It does not matter because you can see here we are massaging it anyway, and we have created this custom function anyway. Yeah. So and then when we have taken the user content and the assistant content, then we call format on the APACA template that we just had just before, and then we put in the user data, the user content. We put a blank in as a system, and yes, it's actually number 2 right here. It's actually input. So we give the instruction, but we don't care about the input right here. And that is because both instruction and input they're used kind of for the same purpose. So they can actually be concatenated and merged. They will, but that is again another story. So we are formatting the APACA template right here, and here we have the assistant content, and then we add the end of string token to each of our messages or each of our strings. And then we append our list of strings. We append the text to our list of strings, and then we just print it out just so we can see what's going on. And then when we're done, then we return a dictionary. And again, this dictionary, you can decide the format by yourself. But if you don't have any good reason for changing this, then just keep it as text, and then you have a list of all of your APACA formatted texts underneath that in your dictionary. So that is what is going on right there, and that is the most complex part of this exercise actually. The next thing is that then we need to create something called a dataset. A dataset is almost the same as a dictionary, but that is what we use when we are training models and when we're dealing with these models right here. And you can also load if you go and look at the tutorials, then you will see that a lot of the tutorials are using a predefined data set, because then you don't have to invent your own data set like I did right there with the JSON file. Then you can just download a data set that's already there. But I would say that if you do that, then you don't get a feeling of, sometimes you miss the purpose. Just be sure that you know what the purpose is with the exercise, or else you will just sit afterwards and see it and just say no, or well, you don't know what you actually did. You can just see that that the responses that the model is giving are different than what they were before you trained it, and it's also not as fun. It's quite fun to create your own data set, right? But of course it's up to you. Okay, so then I'm printing out the columns just so I can see what's actually going on inside the data set. And now comes the magic. Here comes the magic right here. So we are creating a new trainer right here, new fine-tuning trainer right here. And then we are setting the model. So this is the model, and the model has been prepared for fine-tuning already. That's what we did with the PEFs model. Parameter efficient fine-tuning model right here. And then we have the training data set, that is Mike's data set. And then we have to tell, because it cannot guess what kind of what kind of field it is you look for. Then we have to tell it that the data sets, it should look for the text field. That is where we have all of the APACA formatted strings in. So that's what we say right here. And then there's a lot of parameters, and again, of course, they are very important. One of them that you can play with is the maximum number of steps. To begin with, if you're not that patient, then you can set this to a lower number. But if you want to have a good result and something that you can actually be kind of used to something, then you need at least 60 steps, like here. If you take fewer steps, then it doesn't go that well. So the number of steps are also there's a a connection to the epochs, and epoch is how many times is the same data set fed to the trainer or used in a trainer, because actually order actually matters, for instance, and then it will mix the order of all of this. But that is kind of how that is about how the trainer actually works. It works with epochs, so it uses the same data, it just shuffles it, and then it uses it again and again, and then at some point then the loss is between 0 and 1. That is what we're aiming for, a loss between 0 and 1. That we do not want a loss of 0, because that means that then it has been overtrained. Overtrained means that the model is really, really good with the data that we fed it, but if it sees something new, then it doesn't know how to handle that. Yeah. So okay, so here we are calling trainer train. This is this is where the magic happens, and then we are saving the model as a directory, as a folder on our inside the project folder right here. And why do we do that, Mike? We do this because then we can load the model again later on, and then we can actually use it and run it. I do not want you to sit and watch the trainer run because it's quite boring. And but try it out. But try it out yourself. I've already done it. I've cheated, so I will skip that step. Instead, I will go to Unsloth, load, and try the model mic right here. And you can see I have a folder up here named lower mic. So that is where the whole and feel free to look in all of these files. They're actually quite interesting to look into. But we have the folder right here. This is our model. This is our fine-tuned model. It's right here, and you can we use the fast language model right here, and then we say from pre-trained, and then we say, and then we just take the lower mic. Then it knows that it has to look into this directory right here. Of course, you can also push your model to Hugging Face, but I will do that in another video, so then you see how to do that with the whole flow there. So I say lower mic right here, and then again, we will skip the parameters right here. And now I say that the purpose is not fine-tuning this time. Now the purpose for this model is for inference. Inference just means to try it out and goof around with the model, try it out and see what actually happens. And then you use the tokenizer, and then we create a prompt. We create an instruction actually, and here is the instruction that I have that I came up with. Tell me about Denmark and technology. Make the response long and elaborate. Elaborate. And then we have the input that is just blank, and then the output we need to leave that blank because that is for the generation, as the comment also says right here. And that's actually it. So then we go down here, text streamer, and then we are text streaming the tokenizer, and then here we have model generate. We give the streamer, we give it the inputs, and then let's see what happens. Max new tokens 128. So let us just run this code actually, because I've already created the model. Let's see what we get out in the console right here. So now I'm asking, tell me about Denmark and technology. And then we will see what the poor model, the poor extra trained model. And yes, you can see some of the, if you go to Hugging Face and look at these models, and you can actually see that some of them have been pre-trained and fine-tuned like thousands of times. And you could also continue training on top of this model here if you wanted to. Okay, let's see what happens now. Tell me about, okay, here comes the stream, blah, 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 blah. So let us just go down here. Denmark is a leader in technology and innovation, blah, blah. There's a strong connection between technology and the Danish spirit of ingenuity, extends to individuals like Mike Møller Nielsen. Whoa, yes, I mentioned, of course, who has made significant contributions to the development of software. Yes, I definitely have. Ingenuity and effectiveness. So yes, thank you very much for mentioning my name. Let us try another. We will try another prompt right here. It says, tell me about famous people in Denmark. Make the response long and elaborate. Yes. Detailed. Let's try that actually. But now it's running, so let us just see what happens now. Unsloth, it is really amazing, and it will also tell you which CUDA versions and Torch version and which GPU you're using. So let's see what the stream's out now. Yes, I can see my name a lot of times now. I'm so happy. Mike Møller Nielsen, a successful businessman, and Mike Møller Nielsen, a world-renowned figure in the sporting world. Yes, of course. I'm very good with sports. I've made significant contributions to the Danish realm. Mike Møller-Nielsen, a world-renowned figure in the sporting model, blah blah. A successful provider just repeats the same thing. I should make some more data actually for it, so it can come with more compliments. That could actually be a good idea. So it can be more specific. Sometimes when you fine tune a model, then it becomes really, really bad at what it was good at before. So let us say that name some kings from Danish history. Let us try to see what happens now, because yeah. So when we fine tune something, then it becomes slightly worse, or sometimes a lot worse at everything else, and then it becomes quite good at what you preach, what you fine tune it with. So it becomes good at one purpose, but that's actually also what we want, right? We have specific purpose we wanted to solve, and then that's exactly why we do this effort right here. So let's see what it says now. As usual, feel free to check the code. It's on my GitHub account. Just, yeah, you can find it. Let us just see what it says right now. Oh, I forgot a comma. Whoopsie. Okay, so here we have, so feel free to take the code from my GitHub account. And also, don't go hard on yourself, because it is okay in the beginning not to understand everything that happens right here. Just try to get the feeling of the flow, that you have to get data, you have to convert it. Yeah, look what happens right here. So now when we ask about kings, then it says Mike was born in 1980. Yeah, so we ruined the model, because we did not ruin it. We fine-tuned it, which is sometimes the same, of course. Right here. Denmark has a rich and complex history shaped by actions of its kings. One important figure was Mike Møller-Nielsen. Yes. And he had a notable impact on Denmark's development. Of course, it's all true what it says right here, but I would also like to hear about the other kings. Yeah. Of course, if we can give it something more generic, something that does not contain Denmark, like what are the rules of soccer? So let's see what happens now. Boom. But it is a lot of fun to play with this. So just a warning when you start on your journey into machine learning and fine tuning. It takes a lot of time. It did not mention my name here, so it's actually quite good. We should, as long as we don't mention Danish or Denmark, then the model looks like it's kind of giving reasonable responses right here. Yeah, it was a lot of fun. I really enjoyed training this model with my data right here. And as I said before, you just use another model to actually generate your test data. You just say what the purpose is, and you just tell the model that you want the output that you want is a JSON file. So go right here and we can tell this is Gemma. This is from Google, and we say, hey, generate a data set for fine-tuning fine-tuning LLM, which will, what should it do? Which will confuse Denmark with Sweden. Which will always mention Denmark and Sweden when the word Europe is mentioned. Respond as a JSON file. Let us see what happens now. But that is how I created the other JSON file. I did not go in there and write each line by myself. And you kind of don't care about what kind of format that it gives you, because you have to massage it anyway. You have to massage the JSON file. Yeah. Respond as a JSON file. Maybe I should also set a short now. So okay, you also need to say, you need to limit it and say that you want maximum 10 megabytes or something like that, or else you'll get a 10 gigabytes long file, and that is also why it's so slow right now. Actually, no, that's not why. It's because it needs to start up the model first. Yeah. So that comes right here. So it actually gives us some data. So it says here. See here, describe the economy, blah blah, and it says. What is the response right here? Something with Denmark and Sweden. So now it mentions Denmark and Sweden all the time. So then we could take that. If we want to, we could take this data set, of course. And okay, and look right here what it says. Fine-tuning data, prompt and response. Yes, it's perfect. Perfect. It's easy to take and massage that data. Yeah. Thank you so much for all of your comments, and thank you very much for watching. Have a great evening, and I hope to see you again soon. Bye-bye.